Hello guys, today I'm going to teach you question number 7 for TRIAL exam Kedah Merbok. So this one is actually modulus function, right? So for modulus function, basically you should know modulus x is equal to positive and negative x, right? So for this one, you have to do the same. The concept is that this function you should be able to express in positive and negative with a negative 2x squared plus 4. Alright, so that means you should know this function is a modulus function, so it can actually means that you have positive function negative 2x squared plus 4, or you can have positive 2x squared minus 4 if you multiply the negative inside. Alright, okay, it means that alright, so this one is a bit confused. So you times in will be positive, you times in will be negative. So in fact you have two functions, right? Okay, so that is actually basically the concept of modulus. So now the question is asking you to find the equation of tangent, right? Equation of tangent. So whenever you see equation of tangent to the curve, it means dy dx. Alright, for here, because they give you f, so you should know that this is the first derivative. Alright, okay, I'm going to find the first derivative at x equal to 2. Now you have to study the function. So function means graph. So I think we need to sketch the graph. Okay, before we find the differentiation of first derivative at x equal to 2. So we just sketch a simple graph, alright? So how to sketch a graph? Basically, when you want to sketch a graph, this is a modulus graph, so you have to find the point. So let's say fx, I assume is this one first, 2x squared minus 2x squared plus 4. So when y0, you can find the x intercept. So x squared is 4, 2x squared is 4, that means x squared is 2, that means x is positive, negative 2. That means the graph will actually, if you sketch, the graph will intersect at here, negative 2 and 2. Understand? Alright, now we need to find the y-intercept. For y-intercept, you need to let x0. So if x0, that means the y is 4, right? So the 4 is here. Let's say this is 0, 4. Okay, so basically if you sketch this function without modulus, it looks like this. I just sketch for you. I change the color. It's like this. I think this one you sketched before is an N shape, right? Okay, something like this. Okay, so this is a graph for the this function. But now we are having modulus. Don't forget we're having modulus. So I'm going to change it to modulus. So if immediately I put two lines, the graph, the negative part, this part will go up. It will be like that. It will reflect up. Alright, again I show reflection, and this side also it will reflect up. Okay, so basically the modulus graph that represented by the graph is this one. Alright, it's a graph. I make it thicker so that you are okay, clear. Okay, now the question is asking you to do what? You're asking to find the gradient of tangent, then you have to find the equation of tangent, right? So let's say this is 2 is higher, square root 2 is 1 point something, or is it, you press the calculator, so 2 obviously is right, to the right of the search tool. So at this point, right, so on the curve you're asking to find a tangent, equation of tangent. Before you can find the equation of tangent, you must have gradient of tangent. Now let's sketch the tangent. What it means by tangent actually? Tangent is a straight line that touches the curve at a point. So I'm going to sketch now. So you see, I use a black color. So let's say this is a tangent. It touches a red point, then it's a straight line. It's a straight line. So this straight line, okay, it passes through 2 and okay. When x2, y will be, you can substitute into here, -8, right? -8 plus 4, -4, so be +4, right? Okay, I have the point right here, this point, the black point, and the line passes through the black point is actually the equation of tangent. Understand? It touches a curve, right? It touches a curve at a point, so this is a line. Okay, so now we want to form the equation for this yellow line. So you must have the gradient, right? The gradient for the tangent to the curve is always using dy dx, so it looks like it's positive, right? So okay, your dy dx is here, so this is actually 4x, right? If I choose, I will choose this one, 4x. all right, f prime x will be positive, so f prime x will be 4x. So it means dy dx is 4x. We used to use dy dx, right? Okay, so we have 4 times 2. That means the m is 8. Okay, you have the point there, 2, 4. Okay, how to form the equation? Y equal to mx plus c. You have the point 2, 4. So 4 equal to m is, gradient is, just now we have the gradient is, what's the gradient? 8, right? 8 times 2 plus c. So the c is 4 minus 16, which is -12. So the equation of tangent, write again, y equal to 8x minus 12. That is the equation of the tangent to the curve. Okay, understand? Okay, equation of tangent to the curve at a point. To the curve at point 2, 4, right? Okay, so this is the equation of tangent, is a straight line. Settle, we have solved the equation of tangent. Now the second part is at x equal to 2. Okay, we have the equation of tangent. This, the yellow line, is actually y equal to 8x minus 12. Clear? Understand? Okay, we have find the equation of the yellow line, which is representing by this equation, right? Okay, so settle equation tangent. Now we proceed to the next one. Is they ask you about the gradient function, right? Whenever you see gradient function, it means dy dx. Okay, it means dy dx. So I'm going to write dy dx equal to 4x minus 4x. Okay, this is gradient function given, and then has 2 turning point. Okay, whenever you see turning point, you should be able to let your dy dx equal to 0, right? Okay, now we need to solve this. 4 over x become like this, right? So it's 4x squared equal to 4, right? So that means your x squared will be 1. That means you have 2 values, plus minus 1, right? Okay, so that means your h can be positive, can be -1. Alright, now the question says find the value of h. Okay, then hence by determine the second derivative. Okay, we have to do second derivative, right? To determine the maximum minimum point, you have to use the second derivative. So here, d2y dx squared. So the dy dx we have just now is 4x minus 4x negative 1, bring up the power. So okay, we differentiate one more time, will be 4 plus 4x negative 2, right? Alright, now we need to substitute the 1 and negative 1 into the d2y dx square. Okay, you can write like this: f double prime is 4 plus 4 over x square, right? Right, okay, bring down the power. So at x equal to 1, f double prime 1, second derivative 4 plus 4 is positive. So if d2y dx square positive more than 0, that means it's a minimum point. Okay, so that means at x equal to 1 is a minimum point, and when x equal to negative 1, d2y dx square or f double prime negative 1 is actually 4 plus 4 over negative 1 square. It's also 8, right? So that means it's also a minimum point. That means at x equal to negative 1, this is more than 0, is a minimum point too. That means both points are actually minimum point. Alright, so it happened at x1 and negative 1. The turning point are actually minimum point. So that means both points are minimum point. Right, minimum point. Okay, understand? So that means you do the second derivative. If it is positive, that means it will be minimum point, d2y dx squared more than 0. Okay, so conclusion is minimum point. Alright, so we have proved it is minimum point because we find the value of d2y dx squared. Both points are having positive value of the second derivative. Alright, so this one is about the differentiation and also the curve. So actually it's not easy because you need to understand thoroughly the modulus graph, and then you need to understand what is gradient of tangent, right? Okay, and then you have to be very careful when you do differentiation, and you must memorize the fact that if you do second derivative, if it is positive, then it is minimum point, negative will be maximum point. And also you must know how to find the equation of tangent. Alright, so that's all my sharing for question number 7, which is quite tough. So I take time to explain to you until you understand thoroughly. Alright, okay, so I will share another video for the balance of the question slowly. Okay, with that, I shall see you in my next video sharing. Bye bye and have a nice day. To be continued. See you soon. you.